To solve the problems given in the fourth exercise, we have to derive the trigonometric identities, which are very simple. To derive them, let us consider a right angle triangle ABC. So we have triangle ABC with angle B equal to 90 degrees. Now this is a right angle triangle, and we know that AC square equals AB square plus BC square. Okay, so this is according to Pythagoras theorem. Now let me divide this expression by AC square. So I divide this expression by AC square, both the LHS and RHS. So I get 1 equal to AB square by AC square plus BC square by AC square. Okay, so now if I consider the angle here, according to angle C, what is AB by AC? AB is the opposite side by the hypotenuse, which is sine C, the whole square, plus what is BC? BC is the adjacent side by hypotenuse, which is cos C, the whole square, which is equal to 1. Right? So this happens to be the most important relation which we get, wherein sine of an angle square plus cos of an angle square is equal to 1. So in general, we write this expression as sine square theta plus cos square theta equals 1. So this is the first relation. Next, let us again consider this expression AC square equals AB square plus BC square. So let me write this here. AC square equals AB square plus BC square. So to get the first relation, what did we do? We divided it by AC square. And now to get the next relation, let me divide it by AB square. So dividing LHS and RHS by AB square. So what do I get? I get AC by AB the whole square. So which implies AC by AB the whole square equals 1 plus BC by AB the whole square. So here, when I divide the entire expression by AB square, I get AC by AB the whole square equals 1 plus BC by AB the whole square. Now what is AC by AB? AC is the hypotenuse and AB is the opposite side. So we know that opposite side by hypotenuse is sine. That is what we have seen here, isn't it? AB by AC is sine. What is AC by AB? It is the reciprocal, so it is cosecant square. So cosecant square C equals 1 plus. Now what is BC? BC is the adjacent side divided by the opposite side. So the adjacent side divided by the opposite side is cot C the whole square. Okay, so we have the next expression which says 1 plus cot square C equals cosecant square C. So I write the expression. So 1 plus cot square theta in general is cosecant square theta. Okay, so remember we have just taken this expression, which is nothing but according to Pythagoras theorem. So first we divided by the hypotenuse, I get the first expression. Next I divided by AB square, I get this expression. Now what do? I have to divide it by BC square, right? So now the same expression here. So AC square equals AB square plus BC square. So now I divide the LHS and RHS by BC square. So what do I get? I get AC by BC the whole square equals AB by BC the whole square plus 1. Okay, now what is BC? BC is the adjacent side and AC is the hypotenuse. Okay, so now we know that adjacent side by hypotenuse is cos. So here it's cos C. So BC by AC is cos C. So I have the reciprocal here. So reciprocal of cos C is secant C. So I have secant C the whole square equals AB. AB is the opposite side. BC is the adjacent side. So opposite side by adjacent side is tan C the whole square plus 1. Okay, so in general I can write the expression as 1 plus tan square theta equals secant square theta. Now, how did we get these three trigonometric identities? We got them by considering the right angle triangle ABC, writing this expression according to Pythagoras theorem, which states that AC square equals AB square plus BC square, and then by dividing this expression by the hypotenuse square, and then by the opposite side AB square, and then by BC square, we get these three relations. Okay, so make sure that you watch the next video where using these three trigonometric identities we will solve all the problems given in the fourth exercise. Do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and thanks for watching.